All right, today we're going to pull back the curtain on something you've probably never even thought about, but it's absolutely essential to keeping our world running. We're talking about the unsung hero of industry, the silicone hose. So let's just jump right in. Put yourself in an engineer's shoes for a second. You have to build a system that can handle blistering heat, insane amounts of pressure, and some seriously nasty chemicals, all at the same time. I mean, what kind of material do you even turn to? What could possibly stand up to all of that without failing? Because let's be real, in these kinds of jobs, we're talking food processing, pharmaceutical labs, high-performance engines, failure just isn't an option. One little component breaking down isn't some minor inconvenience. No, it can mean shutting down the entire operation, contaminating a whole batch of product, or even worse. Reliability is literally everything. And here it is. This is the answer to that impossible question. Meet our hero for the day. The silicone rubber hose. Now, I know, it might just look like a simple tube, but as you're about to see, this thing is a masterpiece of material science, specifically engineered to thrive in the toughest conditions imaginable. So what is the secret sauce? What makes the stuff so special? Well, let's get into the science of it and unpack silicone's incredible superpowers. First off, its ability to just laugh at extreme temperatures. Seriously, we're talking about a material that stays perfectly flexible and strong, whether it's in a deep freezer or carrying fluids hot enough to boil water. It's not going to get brittle and crack when it's freezing, and it won't turn into a mushy mess when it gets hot. Next up is its chemical personality, or really, its lack of one. Silicone is what scientists call inert. Basically, its molecular structure is super stable and just doesn't want to react with other chemicals. This is beyond crucial for things like food and medicine, right? You absolutely cannot have the hose itself leaching weird stuff into your product. This ensures everything stays pure. Okay, now this property is really cool. It's called compression set. Here's the best way to think about it. If you squash a cheap kitchen sponge, it kind of just stays squashed, right? Well, silicone is like high-end memory foam. You can compress it and it bounces right back to its original shape. That ability to bounce back is what lets it keep a perfect, reliable seal for years and years. So we've established the material itself is incredible, but the way it's constructed is just as important. So let's peel back the layers and do a little anatomy lesson on this super hose. Yeah, just look at this cross-section. You can tell right away this is way more than just a simple tube. Every single part you're seeing is a distinct layer, and they all work together as a complete engineered system built for one thing: performance. It really comes down to these three critical layers. That perfectly smooth inner layer, that's all about purity and making sure whatever's inside flows without a hitch. Then you've got that woven middle layer, the reinforcement. That's the muscle. That breeding is what keeps the hose from literally exploding under high pressure. And finally, you have the outer layer, which is like a tough bodyguard, protecting everything from the outside environment: sunlight, chemicals, scrapes, you name it. And to get even more granular, not all silicone is created equal. How it's made, the curing process, matters a ton. Platinum-cured silicone, that's the absolute gold standard, especially for food and medical uses. Why? Well, it leads to fewer extractables, which are just microscopic particles that could potentially leak out. So for the highest level of purity, platinum is really the only way to go. And here are two last keys to why this thing is so dependable. That reinforcement we talked about, it's often made from super high-strength polyester or even a remed fabric, which, by the way, is in the same family as Kevlar. And it's also designed with a great bend radius, which is a fancy way of saying you can bend it pretty tightly in cramped spaces without it kinking up and choking off the flow. Okay, we've gone through a lot of the technical details. But so what? What does all this actually mean in the real world? Let's connect all this back to the real-world impact and really understand the true cost of getting it wrong. I love this quote. It's so simple, so direct, but it's 100% true. A hose that kinks is a hose that fails. If it kinks, flow stops. And if flow stops, your whole process fails. It's really that black and white. So at the end of the day, it all boils down to two very different outcomes. On one side, you choose the right component and you get a smooth, efficient, profitable operation. You have product purity, safety, and machinery that lasts. But on the other side, you get unexpected shutdowns, expensive delays, compromised products, and just one giant, costly headache. The stakes are just incredibly high. And that really wraps it up. It kind of makes you think, doesn't it? I mean, if there's this much incredible science and engineering packed into what looks like a simple hose, What other everyday things are all around us, just hiding a whole world of complexity right in plain sight?